Hello, this is Satbir. The topic of our discussion in this video tutorial is the combination. So what is a combination? Combination is a unordered selection. So when we have to select a certain number of object, when the order does not matter, we use the method of combination. Here I also want to mention the combination is the special case of product rule and the division rule. Actually, we will use the product rule and the division rule to find out the formula of combination. Now to get some better understanding of this concept, let's take few examples. Our first example is how many different committee of 3 students can be formed from a group of 5 students. So to solve the solution, first I will write down what is the procedure and what are the event. So the procedure is we have to select 3 students. So the selection of the 3 student will be our procedure. And then I will write down the event. So since we have to select the 3 student, it means we have to select the first student, second student, and the third student. So this is the first student, the second student, and the third student. So this is the event and this is the procedure. So the total number of students we have 5. So the 5 is the total number of students. Out of these students, we have to select 3 student, and we have to form the committee of these 3 students. So as you can see that there are 5 students. So to select 1 student out of 5 students, there will be a 5-way. Since the first student we have selected, we cannot select it again. So the second way will have basically the selection of the second student will be done in 4 ways. And the selection of the third student can be done in 3 ways. Also notice the conjunction between these events, selecting first student, second student, and third student is and, because we have to select 3 students. We have to select first student and second student and third student. So the conjunction is and. So therefore the total number of way, to select the student will be 5 multiplied by 4 multiplied by 3. So here there are some repetitions in this procedure which we need to remove. So as you can notice, if I mark the student S1 to S5 and I select S1, S2 and S3, so these are my first 3 students. If I select in the order S1, S2, S3, or I select in the order S2, S1, S3, they are identical. So there are some way which are identical. So we need to basically discredit these way by using the division rule. So also notice that this is not only the one way which is identical to the S1, S2, S3. So if I do S1, S3 and S2, this is also the identical way. In fact, they have 3 factorial way which are identical. If I pick away S1, S2, there are 3 factorial way which corresponding to this one way. Also, if I take a different combination S1, S4, S5, you will see there will be 3 factorial way which will be corresponding to this special way. So each way has multiple way which is corresponding to that way, but all of them are exactly 3 factorial. So we can use the division rule, because in this case the total number of way can be divided into groups where each group will consist of 3 factorial way which are identical to that particular way. So no matter if you pick any combination or if you pick any combination of 3 students, there are 3 factorial way which corresponding to that combination. So therefore we will divide this by 3 factorial, because there are 3 factorial way which we have to discredit from these number of way, which is 5 times 4 times 3, in order to calculate all the way which do not basically take account of the orders. If I calculate this one, this will be a 5 times 4 times 3, which is a divide by 1 times 2 times 3. This 3 will cancel out, this 2 will cancel out to 2, so this will be a total number of way will be 10. So there are 10 different way to select 3 student out of 5 students. So now let's find out what will be the general formula of the combination. So as you can see that here in this problem, so you have 5 times 4 times 3, which is a divide by 3 factorial. And we can write this fraction also as we can multiply 2 and 1, and we can multiply 2 and 1 in the denominator. So therefore this will become, the top will become 5 factorial and the bottom will become 3 factorial multiplied by 2 factorial. So I write down this problem in terms of factorial. Also notice you can write the 2 factorial. So this is going to be a 5 factorial, 3 factorial. You can write the 2 factorial as 5 minus 3 factorial. The reason is this, because we have 5 students and we choose 3 students out of them. So we want to write everything in terms of 5 and 3. And this is the notation. C is means the choice. We choose out of 5 the 3 student where the order does not matter. It's very important that the order in this problem does not matter. If the order is matter, then we will use the permutation. We will not use the method of combination. So now let's write down the formula for a general case. So as you can see that when you have 5 choose 3, so if you have n choose r, if you have n number of student and you have to choose r, then the general formula will be n factorial. The number of way you can permute, basically the n object, and then it is a divide by r factorial, because this is the number of object you need to choose, and then this will be n minus r factorial. So this will be our general formula for the combination problem. N choose r is equal to n factorial divided by r factorial multiplied by n minus r factorial. Our example number 2 is how many poker hand of 5 card can be dealt from a standard deck of 52 card. To start the solution of this problem, first we need to identify whether this problem is of a combination or is problem of a permutation. So as you can see that we have total 52 card and we need to select 5 card. And the order really doesn't matter in which order we select these 5 cards. So we will use the method of combination. So the total number of card we have is 52, and then we have to select 5 card out of these 52 card. And the way we select these 5 card, there is no specific order which is given in this statement. Therefore, the total number of way will be 52 factorial, and it is divided by 5 factorial. So 5 is here. So 52 divided by 5, and then the difference of these 52 minus 5 factorial. So this number of ways we can basically select 5 card out of 52 card. Now we can simplify. This is a 52 factorial. This is a 5 factorial. This one is a 57 factorial. So if we use the calculator or computer, we can solve this fraction and we will get 2,598,960. So these are the total number of ways we can select 5 student out of 52 student. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Our problem number 3 is a professor write 40 discrete mathematics true false question. Of these statements in these question 17 are true. If the question can be positioned in any order, how many different answer key are possible? As you can see that in this problem also the order does not matter, so we can use the method of combination. So as you can see that this problem is basically we have 40 questions and we have to choose 17 questions and mark them true. So this is the problem of combination. We have total 40 question and we will gonna choose 17 question out of these 40 questions and then mark them true. So that will be the total number of ways you can have the different answer keys, which will be 40 factorial divide by 17 factorial, and this will be a 40 minus 17 factorial, which you can simplify it as a 40 factorial divide by 17 factorial. This will be 23 factorial. Here I have example number 4. In this example, I will show you that where you can use the method of combination and where you can use the method of permutation. So in part A, we will use a method of combination and we will see that why we cannot use the method of combination in part B, where we will use the method of permutation. So our problem is a club has 25 members. In part A, we will find out how many ways are there to choose 4 members of the club to serve an executive committee. So let's solve first part A. So solution of part A. So in part A, as you can see, we have 25 club member, and we need to choose 4 of them. So this can be solved by the combination, the method of combination, because we have 25 member and we will choose 4 member, and the order really doesn't matter in what order you choose. You choose the person P1, P2, P3, P4, or you choose the person P4, P1, P2, P3. So the order since does not matter. All you have to do is you have to select the 4 member, and that's all we need to do. So this is the method of this problem can be solved by the method of combination. So by the method of combination, the total number of way will be 25 choose 4. Therefore, this is a 25 factorial divide by 4 factorial, and 25 minus 4, which is a 21 factorial. And if we basically simplify this factorial and write in term of a number, we will get so these are the total number of way we can choose 4 member committee out of 25 member. However, in the problem number 2, you see that the order is really matter, because once we select the person, either we have to make him president, vice president, secretary, or treasurer. So the order really matter. So in this case, you cannot use simply the combination or the selection. You cannot just select the out of 25 4 and then basically put them in any order, because order is really important. The order is important in a way that first you have to make the president, then you need to make choose the vice president, then you need to choose the secretary, and then you need to choose the treasurer also. So these order really matter. So if you have total number of 25 member, and you need to select 4 member, and all these 4 member, when you put them into the order, so this order is matter, so we cannot use the method of combination. Instead, this problem is the can be calculated by the using the method of permutation. So therefore, by the method of permutation, the total number of way will be, because if I select the president, and there will be a 25 way to select the president. So this will be a 25. And then if I select the vice president, there will be a 24 way, because I already selected the president. I cannot select that person again. And then I can select the secretary, which is a 23 way, and then I can select the treasurer, which is a 22 way. So this will be the total number of way, because the conjunction in this problem is and. Therefore 25, 24, 23, and 22, these are the total number of way to form a committee where you choose a president, vice president, secretary, treasurer of the club. And no person can hold more than one position. Therefore the repetition is not allowed, but the order does matter. For example, if you give them the name to these 25 member, and you can say C1, C2, C3, C4 will be a one way to assign these 4 role to these first 4 member of the club. And if you assign C2, C1, C3, C4, so these two way will be a different, because in the first way the first person was the president, in the second way the second person was the president. So these are the two different way, it's not the identical way. So we do not need to discredit the repetition. So in this case we just will use the method of permutation. Now if you simplify this number, which is you have to multiply 25, 24, 23, and 22, you will get. So this is the major difference between the problem of permutation and the combination. In the combination, order does not matter, but in the permutation, order does matter. Okay, this is also the end of this video. Thank you very much for watching. So I will see you in the next video. Bye for now.